Oh no, we're in trouble. We're back again. And once again, we're comparing fractions. And yes, this is a different video, so I'm calling this Comparing Fractions 2. The reason I'm putting this together is to um, potentially look at a problem we've done before, order from least to greatest. And we have some fractions here, but to do it in a couple different, some other ways that um, you can think about things. And this hits on two ideas specifically. One, we've said this many times before, there are many ways to write numbers in order to think about numbers. And in this case, it's good to point out this other big idea that our number sense grows through experience. The more we work with numbers and move them around and manipulate them, the more we can do with them. It's just like practicing anything. The more you practice, the better you get at things, the more you can change things around. So here, what we're going to do is we're going to take, these are two different sets of fractions, and we want to order them from least to greatest. The previous video, we just simply multiplied each fraction by the denominator of the other fractions. So 8 would have been multiplied top and bottom by 4 and by 9. This would have been multiplied top and bottom by 8 and by 9. And this fraction would have been multiplied top and bottom by 4 and by 8. And that got to be kind of unwieldy, and we had sort of large fractions. Then we looked at changing everything into decimals and just comparing decimals. Well, there are other ways, and that's what this little video is going to try and get us to consider. One way is just considering each fraction carefully and seeing if there's anything about them that we might notice. And in this case, one thing that's noticed is that only one of these three fractions is greater than 1/2. And that's going to be 3/4. Now, 3/8 is pretty easily seen. This has to be less than 1/2 because 4/8 is 1/2 and 3/8 is less than 4/8. So this is less than 1/2. And 3/4 is more than 1/2 because 2/4 is 1/2. Now let's look at this. Well, if I double 4, I get 8, don't I? And 8/9 is still not 1. So this is actually less than 1/2. Half of 9 being 4.5. So this right here is the only fraction of these three that's actually more than 1/2. So that means 3/4 has to be my largest value. So my largest is going to be this. Now, I just have to consider, well, which of these two is larger? And so instead of multiplying, each fraction by two other numbers, now I just need to consider these two. And so I would have 3/8, and here's 4/9. And that means I'm going to have to multiply each fraction, top and bottom, by the other fraction's denominator. So multiply this top and bottom by 9, and I'll multiply this fraction, top and bottom, by 8. And when I do that, I have 72 as a denominator in both. 3 times 9 is 27. 4 times 8 is 32. So, because I was able to eliminate this 1, I only had two fractions to deal with, and I could see that from least to greatest is going to be, let's see, 27, this 27, 72 is less than 32 70-seconds, so 3/8 is going to be the least. The largest is going to be 3/4. That I determined when I realized this was the only fraction that's greater than 1/2, and that leaves 4/9 in the middle. So there's my order. So that way I didn't have to deal with, multiplying denominators twice. So here, that was one technique, is just see, is there a way that you can tell if one value is clearly larger or smaller than others, then you only have to deal with the other two. Let's go over to this set of numbers. Now, it would work, again, if I was to multiply each fraction by the other denominators. So 2/5 will be multiplied by 10 and 3, top and bottom. 3/10 I'd have to multiply by 5 and 3. And 2/3 I'd have to multiply by 10 and by 5, top and bottom. And you can see that gives me 5 times 10 is 50. 50 times 3 is 150. So if I do that, I'm dealing with a denominator of 150. And that's just kind of getting large and unwieldy. However, it may be possible that there's a number a lot less than 150 that can work for all these. And this is where just being familiar with your numbers. And specifically, is there any one number that I can divide by 5, 10, and 3? So, notice for a second, if I multiply 2/5 top and bottom by 2, 2/5, if I multiply it by 2, top and bottom, then I have 4/10. And right away, that allows me to compare with this fraction without even having to change this fraction. And if I notice, now I just have 10s and a 3. So I can continue the process by multiplying this by 3 and this by 3. And my 2/3 I'm going to multiply, let's see, let me write it down here. I'll multiply it by 10. And that will leave me with 12/30, with 9/30, and with 20/30. So now I have everything in terms of denominator 30, which is a lot less than 150. That's convenient. And I can easily see that it looks like 3/10 is going to be smaller than 2/5, which will be smaller than 2/3. Of course, if I notice that, hey, 30, I can divide 30 by 5, by 10, and by 3. And if I do that, I can work it this way. So I know that I can divide each one of these 30 by 5, 10, and 3. So I know I can have a denominator 30. The question is, what do I have to multiply 5 by to get to 30? Well, I would multiply 5 by 6. I'll write it below here. I wish I'd leave myself more room, but I didn't. So 2/5, if I multiply it by 6, top and bottom, that'll give me 30. And then 3/10, what do I have to multiply 3/10 by to get to 30? Well, I have to multiply that by 3 and I have to multiply that by 3. And then 2/3, I'll have to multiply this by 10 and this by 10. 2 times 6 is 12. 3 times 3 is 9. 2 times 10 is 20. So this time, I just noticed that 30 was one number that I can divide evenly by 5, 10, and 3. And then I just made 30 my denominator and asked, what must I do to the numerator? What must I do to the denominator to make it 30 and then do the same thing to the numerator? Well, there you go. So here was a couple other ideas. One is changing the denominators to something other than multiplying all 3, which does work, but sometimes it yields a much larger number. With only 3 numbers, if you can eliminate one of the numbers as clearly larger or smaller, then you only have 2 numbers to deal with. But whether we're changing either technique, it's an illustration of this, that our number sets grows through experience. And so the more familiar you are with the numbers and how they can fit into each other, the more you can take advantage of these other methods. I hope this helps, and I'll see you guys real soon.